Table of contents. Types of computer network, hubs, switches, routers, firewall, DHCP server, protocols, and port numbers. Types of computer network. Personal area network, PAN. Local area network, LAN. Wireless local area network, WLAN. Campus area network, CAN. Metropolitan area network, MAN. Wide area network, WAN. Personal area network, PAN. Ultra-small networks used for personal use to share data from one device to another. Can be wired, PAN or wireless, WPAN. USB, Bluetooth, NFC, ANT+. Examples: smartphone to laptop, smartwatch to smartphone, smartphone, hands-free car, calling heart rate monitor to smartphone. Local area network, LAN. A computer network within a small geographical area such as a single room, building, or group of buildings. Considered to be self-contained. All devices are directly connected via cables and/or short-range wireless technology. Doesn't require a leased telecommunications line from an internet service provider, ISP. Examples: home network, small business, or office network. Wireless local area network, WLAN. A LAN that's dependent on wireless connectivity or one that extends a traditional wired LAN to a wireless LAN. Most home networks are WLANs. Campus area network, CAN. A computer network of multiple interconnected LANs in a limited geographical area, such as a corporate business park, government agency, or university campus. Typically owned or used by a single entity. Metropolitan area network, MAN. A computer network that interconnects users with computer resources in a city. Larger than a campus area network, but smaller than a wide area network. Wide area network, WAN. A computer network that extends over a large geographical distance, typically multiple cities and countries. WANs connect geographically distant LANs. Typically use leased telecommunications lines from ISPs. Examples: the internet corporate offices in different hubs, used to connect devices together within a network, used in early networks, replaced by switches, multi-port repeater. Traffic goes in one port and is repeated, broadcasted out every other port, OSI Layer 1 device, dumb network device, causes increased network collision errors, much less efficient than a switch, legacy equipment no longer used. Switches, connects devices together, just like a hub. Intelligent network device, OSI Layer 2, memorizes the MAC address of each device connected to it via a MAC address table, sometimes called a Content Addressable Memory, CAM table. Pays attention to source and destination. MAC addresses during the communication process. Use application-specific integrated circuitry, ASIC, which makes them extremely fast. Breaks up collision domains. Traffic goes in one port and is repeated out to only destination port, designed for high bandwidth standard in today's network infrastructure. Routers, used to connect different networks together, routes traffic between networks using IP addresses, uses intelligent decisions, routing protocols, to find the best way to get a packet of information from one network to another. Break up broadcast domains. OSI Layer 3, Device Layer 3, Azure Router Layer 2, Azure Switch Layer 1, Azure Firewalls. Firewalls are the foundation of a defense-in-depth network security strategy. They protect your network from malicious activity on the internet. Prevent unwanted network traffic on different networks from accessing your network. Firewalls do this by filtering data packets that go through them. They can be a standalone network device or software on a computer system, meaning network-based, hardware, or host-based, software. Types of firewalls, packet filtering. Firewalls, first generation and most basic, basic filtering rules, circuit-level firewalls, second generation, monitors, valid invalid TCP sessions, application layer 7, NGFW, firewalls, Third generation, much more advanced, covered later in course. DHCP server, dynamic host, configuration protocol, DHCP, server, automatically assigns IP addresses to hosts, makes administering a network much easier. An alternative is static IP addressing. We'll talk more about DHCP later in the course. Protocol that automatically assigns IP address configurations to devices on a network. IP address subnet, mask default gateway DNS server. We'll be discussing how DHCP works in detail in the assigning IP addresses section of this course. Uses two UDP ports, 67 and 68 by protocols and port numbers. Thank you for your attention.